Hey everyone, in this lecture we will be understanding the generalized version of permutations and combinations. So this is going to be a very important topic to understand. I think majority of the questions that might show up in your exam or whatever you're trying to prepare for could be from this topic in terms of permutations and combinations, right? This is also going to be our final lecture on permutation and combination. So after this we will be starting with binomial theorem. Okay, so we're going to understand two things. First, we're going to understand two different formulas for permutation. And the main topic of this lecture would be understanding permutations with repetitions. And it would also be understanding combinations with repetitions, right? Okay, let's just take a quick look at a summary of what we covered in the last lecture. So the idea is, consider this example, right? How many 4-digit passwords are possible from the digits 0 to 9? Consider repetition is not allowed. Okay. So we have already covered a similar question to this in the last lecture. I want you guys to pause the video and just solve it. Okay. So let me quickly try to solve this question. In this question, you're supposed to choose a 4-digit password, right? Your possible options are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So since repetition is not allowed, in my first case, I can choose any of these numbers. So think about how many choices I would have. I would have 10 choices. Okay, so once, let's say I chose 1 as my first choice. So how many choices would I have in my second option, in my second pin? I can only choose from 0, 2, 3, 4, 5, 6, 7, 8, 9, which means I would have 9 options left. So let's say I chose 4 as my second option. Then in my third one, I would have 8. And let's say I chose 7 in my third position, so I would have 7 options left. So in total, how many choices would I have for pins if repetition is not allowed? The answer is 10 multiplied by 9 multiplied by 8 multiplied by 7. Okay. In terms of formula for permutation, this is equal to P of NR. Now, N in this case is how many values are allowed, in our case, which is the values from 0 to 9. So N would be 10 in our case, and R is how many we are allowed to choose, right? So we are choosing 4 values at one time. So R in our case is the value 4, and hence this is P of 10 comma 4. In terms of formula, this is N factorial by N minus R factorial. Okay, so this is just pretty much the summary of the last lecture. If you've not watched that video, I would highly suggest that you do. And now let's try to understand when repetition is allowed. So let me just change this question once. Now if I say repetition is allowed, okay? Once again, we are supposed to pick a 4-digit pin, so I have 4 choices. Once again, R in this case would be 4. Okay, but in this case, repetition is allowed, right? Okay, so first choice, as usual, I would have 10 options, but I want you guys to try to pause the video and think about how many options would I have in the second one. Okay, so in the first one, I have 10, but since repetition is allowed, right? Even let's say I pick 1 as my first choice. It doesn't matter. Since repetition is allowed, I can pick 1 as my second choice, 1 as my third, and 1 as my fourth too, right? I can pick it as many times as I want. I can pick any of these numbers anywhere I want or anytime I want in this 4-time pin. So it could be 9, 9, 9, 9, it could be 9, 2, 2, 2, it could be 9, 1, 1, 1. But in the last case, the idea was if I picked a number, I cannot choose it again. So if I chose 1 as my first one and 2 again, I can only choose a different number. So we had a very limited set of choices, right? In this case, that's not the limitation that we have. So in my first option, I can choose 10 options, right? Since I can choose 1 again and I can choose any number of times, I have total of 10 choices, right? I can choose, that means I can choose 10 again. That means for the third place also, I can choose 10 again, and I can do that again for the 4th time as well. Okay, so the idea is very simple. We were supposed to pick how many 4-digit pins are possible, and we are saying the repetition is allowed, right? And the idea is, since we have 10 numbers, we can choose 10 numbers anytime we want. So 10 choices for the first one, 10 for the second, 10 for the third, and 10 for the fourth, giving you 10 to the power of 4. Okay. Now let's try to think about what's the generalized version of the permutations formula when repetition is allowed. So think about this, right? N is the number of choices that we have. Sorry, N is the number of options that we have, right? So number of choices equal N, which is equal to 10 in our case. Okay. And how many are we supposed to choose? R is 4 and R is the number of we are supposed to choose. So if you get a question of permutation where repetition is allowed, the general formula would be simply N to the power of R. Permutation with repetition. So N equal N to the power of R would be the generalized formula when repetition is allowed, right? I've tried to logically explain why the purpose of formula is. It's just that the formula is very easy to understand. I just wanted to explain the reason behind the formula. And the idea is very simple, right? It's just that this time, whatever choices you have and how many you're supposed to pick, you can just pick them any number of times you want, right? So, but the total value would still remain whatever number of times you can pick it, right? So we are supposed to pick a 4-digit pin. That means R in our case is going to be 4. And we have 10 different choices. We can pick anything from 0 to 9, right? That's why our formula is 10 multiplied by 10 multiplied by 10 multiplied by 10. Okay, I hope that makes sense. Now, let me just try to quickly explain this with the animation as well. Okay, so we have 3 colors, 2 slots, and order matters, and repetition is also allowed. So you can reuse, right? So let's pick red, slot 1, back drops to 2, but since repetition is allowed, right, red comes back again. So pool refills. Now pick for slot 2, all 3 still are there, so you can grab green and sequences RG. So build all 9 now, which will give you like 9 in total. So 3 choices for slot 1 and 3 choices for slot 2, right? So now let's just try to generalize this for n items and r slots. That would give you, for every slot, you get n choices, right? So pool always refills. Now multiply n by r times and you get that's n to the r power. So let's take a look at an example, which is a pin 10 to the 4, plate 26 to the 6, and binary 2 to the 8, and reuse anywhere n to the r. Okay, everyone. Now let's take a look at a very interesting concept, right? Okay, so the idea is we're going to understand permutations with identical items. So I have one question over here and one example. So I'll explain both of them and then we will move on to the general formula. Okay, so the idea is how many ways are there to arrange AAB? Now, you might think from the previous lectures or anything that you have covered so far, you might think that we already know the formula to this question. But I want you guys to think again, right? The problem is that in this case, we don't have 3 distinct letters, right? We have 2 letters that are the same. So let's just think about one example, right? Let's say if I had something like A, B, C, then the number of ways I can arrange it would be 3 multiplied by 2 multiplied by 1, considering repetition is not allowed, right? So that would be 6 ways. But in this case, we have 2 ways, right? That means they're basically the same thing. So if I have something like A, B, A, if I swap these A's over here, that wouldn't make a difference. That would still be the same value. So we need to understand how to count in this type of a question, right? And that's exactly what we're going to be doing in this part. Okay. So first of all, I want you guys to try to pause the video and just try to keep in mind what we're trying to figure out, right? The idea is that this is different from whatever we have covered so far. In this case, we are having identical letters in the same keyword, and we are trying to find a way to arrange them. Okay, so I hope you understand the question now. Let's just try to quickly do one thing first. For now, let's consider this as A1 and this as A2. Okay, so let's say these two A's are actually not the same thing, they are distinct characters. So if I have to pick about how many ways are there to arrange them, I can say A1, A2, B, comma a2 a1b. I can say a1 b a2 comma a2 b a1, and then I can say b a1 a2 comma b a2 a1, right? Okay, so if you look at this, in total I would have 6 options, right? So a1 a2b, a2 a1b, this is basically 3 factorial, right? But now think about this, right? Let's just remove these numbers from a1 and a2 now. So if you remove these numbers, how many are we actually left with? We're left with this would actually be just 1. This entire thing would be 1 again, and this entire sequence would be 1. So in number of options I see, I would actually have only 3 options in total. So my 3 factorial, which is 6 options, is actually incorrect. So what would be the correct count? The correct count would be 3 factorial, but I need to divide it by the number of times the a can be swapped, right? The number of times we have overcounted a. So think about how many times we have overcounted. If I had a1, a2, how many times can you rearrange it? Let's say there were 2 different letters, right? I can arrange it in 2 multiplied by 1 ways. I can always swap a1, a2 and a2, a1. So if you look at in each of these examples, right, I've kind of made it in a column so it makes it understanding better. In the first one, when I had a1, a2b and a2, a1b, if you look at each example, right, all I'm doing is I'm just switching these 2 a's outside, right? So a1, a2 can be swapped with a2, a1. In this example, if I had a1, a2, it can be swapped with a2, a1, right? In the final one too, if I had a1, a2, it can be swapped with a2, a1. So how many total ways are there to switch a's? It's 2 multiplied by 1 times, which is equal to 2 factorial ways. So 3 factorial is the total number of ways I can count, or the number of permutations where repetition is not allowed, and I have distinct characters. So if I have a1, a2 and b, which are 3 distinct characters, but I need to divide it by the value of times I have overcounted the value, which is I can arrange a1, a2 in 2 factorial ways. So the answer would be 2 factorial, which is going to be 6 divided by 2 and 3 in total. And as you can see, the answer in this case is 3 as well. Okay. If you're not able to understand this example, that's fine. Let's try to understand this with this example over here. So the question is saying how many distinct arrangements are of the word Mississippi. Okay, now this is a tricky word to understand. Now think about this, right? We're saying distinct arrangements of the word, meaning repetitions are not allowed in this case, right? But if you look at this, if I rearrange this I with this I over here, that wouldn't make a difference. But in permutations, I might consider it as different objects, or I should say different distinct elements. So let's just give a formula for here, right? First, let me just try to consider that all of these are actually distinct elements. So I'm going to label this as M1. I'm going to label this as I1, S1, S2, I2, S3, S3, S4, I3, P1, P2, and then I4. Okay, so I have 4 S's, I have 4 I's, I have 2 P's, and I have 1 M, right? Okay, so let's consider that all of these are distinct for now. If they were all distinct, then the idea would be very simple to understand. I would simply have 11 factorial ways, right? 11 factorial choices if all different letters. So we can, if I have all different letters, right? So that means I have 11 different elements, and they're saying how many distinct arrangements of the word. So that would be 11 multiplied by 10 multiplied by 9 multiplied by 8, so on until 1, which is basically 11 factorial. So I hope you guys understand where the 11 factorial number comes from. Okay, and that's exactly what we did in this question as well, right? We figured out 3 factorial ways because considering A1, A2 are distinct, and then all these letters are distinct, there would be 3 factorial ways, right? Now let's actually understand that what happens when we have similar elements, right? Now, if I remove these numbers, what should the actual answer to this question be? There's no way that this Mississippi word has 11 factorial arrangements. If you try to possibly think about it, right, that's way too much. Because in this 11 factorial, right, we are considering that even if you replace this S1 with S4, that's being considered a different arrangement. But in reality, if I replace S, let's say we didn't have numbers now. If we didn't have any numbers, then replacing this S over here with this S wouldn't really make a difference. But in this 11 factorial, that's being counted, and that's what we need to divide it by. Okay, so let's just try to understand what we need to do, right? Let's pick the example of I for now. So I have total of four i's. Let me label them I1, I2, I3, and I4, right? Let's just move them all in this place. So let me ask you this question. I say there are 4 distinct characters, I1, I2, I3, I4. How many different ways can you arrange them without repetition? So the answer would simply be, you can say 4 for the first one, 3 for the second, 2 for the third, and 1 for the fourth. This is equal to 4, 3, 12, 24 ways. So if I have 4 distinct i's, right? Let's say I'm saying I1, I2, I3, I4. They are actually not the same word. They are 4 distinct characters. So naturally, they would have 24 different ways to arrange them. Meaning I can say I4, I1, I3, I2. This is one way I can arrange it. I'm just giving a few examples. I3, I1, I2, I4. This would be another way. But now think about this, right? All this 24 times we have actually counted in 11 factorial. So we need to divide it by this number. We need to divide by 24 this 11 factorial value. And that would reduce the number of i's that we have overcounted. Let me try to explain this one more time, right? We have 4 i's in this case. Let's say these i's were actually distinct characters, I1, I2, I3, I4. And if I ask you the question, right, how many different ways can you arrange them? That would be 24 different ways. But if I remove these numbers, then this 24 brings down to just 1. It wouldn't matter, right? If I just move I from one place to other, that's the same thing. So that means that in this 11 factorial value, I've overcounted it. So I need to divide it by this 4 factorial value because my I value in this 11 factorial is being counted over the count, right? Okay. Same thing, consider the value S now. I know it's kind of getting messy, but I'm really sorry for that. If you guys have any suggestions and feedback for me, just let me know. And any improvements I can make in terms of my explanation, I would really be appreciated. Okay, so let me just try to explain this with S now, right? So we have S1, S2, S3, S4. Let's say we had S1, S2, S3, S4. We have 4 S's. Let's consider they were distinct characters one more time. So if they were distinct, we would have 4 factorial ways, right? You can write S1, S3, S2, S4. You can write S2, S4, S3, S1. You can write S3, S2, S1, S4, right? But now once again, you have 4 factorial ways, right? 24 ways. But if I just remove these numbers, they all are basically the same thing. So once again, just like I counted I extra 24 times, I divided it by 4 factorial, right? I need to do the same for the number of times I've overcounted S as well. That means 4 factorial. I'm not going to subtract by 4 factorial. I need to divide it by 4 factorial, right? That's very important factor to understand. Okay, and once again, why are we dividing by 4? Why are we dividing by 4 factorial and not 4 in this case, right? And the idea is very simple. If you have 4 letters, right, there are 4 factorial ways to rearrange it. And this 11 factorial includes that much. So that's why we need to divide it. Okay. Now, same thing we need to do for P as well. We have two P's in our case, right, which is P1 and P2. So that means that we must have overcounted the number of ways we are arranging the P. So, meaning in this, we have counted P1, P2, and P2, P1 appearing multiple times. That means we need to divide this by 2 factorial as well. So, my final answer would be 11 factorial by 4 factorial by 4 factorial multiplied by 2 factorial. And this is the answer. Yeah. Probably a bit tricky to understand. Let me just try to give a summary of this question once again. Okay, so the idea is how many distinct arrangements are of the word Mississippi, right? That's the question, what the question is asking. Now, the problem in this question is that all of these words are not distinct, right? They are different numbers, different characters, I should say. In terms of when I gave you the numbers 0 to 9, right? And I asked you to pick a pin. In that case, you had distinct options. You could pick 0 to 9. In this case, I'm being asked to arrange it. But I have S appearing 4 times, I have P appearing 2 times, and I have I appearing 4 times as well. Now, if I just gave the answer 11 factorial, that would be incorrect. That would mean that I'm overcounting the appearance of I's its own arrangements multiple times, and S arrangements multiple times, and 2 P's arrangements multiple times as well. So what I do is I pick each one, right? Let's pick all the 4 S's. So how many times can we arrange S's? There are 4 factorial ways because we have 4 S's in our case. So if they were actually distinct letters, right? Let's say instead of just being S, we had S1, S2, S3, S4. There would be 4 factorial ways. So that means we need to divide by 4 factorial to remove the overcount that we have done for S. Same thing we did for I, that appears 4 times, and same thing we did for P as well. So this for I, this for S, and this for P over here. So I hope this makes sense. And same thing we did over here as well. First, I told you that let's say we have distinct 3 letters, right? A1, A2, and B. So if they were distinct, that would be 3 factorial ways. But then we had to divide it by 2 factorial because A1 and A2, if we just remove these numbers, they would be basically the same thing. So rearranging them doesn't really make sense. This really just counts to 1. This basically sums up to 1, and this basically goes up to 1. Okay. Now, let me give you the general formula. The general idea is if you have n, the general formula in our case would be n factorial divided by n1 factorial, n2 factorial, n3 factorial, whatever it is. And n1 in this case is n of type 1. This is n of type 2, and so on and so on. The idea is very simple. You first consider all the letters as distinct. So we have 11 different letters, so we do 11 factorial. And then you divide by the number of times you have overcounted a letter. So S is appearing 4 times, so divided by 4 factorial for it. I is appearing 4 times, so divide by 4 factorial. P appears 2 times, so divide by 2 factorial. Now, the general formula is very easy to understand. But once again, I think it's very important to understand the reason behind the formula, right? And that's exactly what I was trying to do with this. Okay, so once again, let me just quickly show you guys an animation to understand this. And I hope that makes sense if the board explanation was kind of tricky to understand, right? From this lecture and like from the upcoming lectures too, I'll try to put on more and more animations after my explanations on the board. So it's just that if there was any doubt left in your mind, that animation covers the rest of it, right? And obviously you guys can always pause the video and just rewind back and watch the video again. Okay, now let's move on to the next topic. So let's just take a look at an animation, right? We have 3 letters, B, A, A. Now let's just consider they are different. So that gives you B, A1, A2 and all these examples, which is 6 different arrangements equal to 3 factorial, right? Now let's just drop the labels, right? They were never different. So every arrangement has a twin. Pairs collapse and 6 becomes 3, which is divided by 2, right? Because 2 A's can swap. Now the rule is n factorial divide by each group's factorial, right? So let me show you guys an example of this, which is the Mississippi one again. So Mississippi has 11 letters, all are different, which is 11 factorial, which is 40 million, right? That's way too much. But we have four I's, we have four S's, we have two P's, and each group shuffles, right? So we can divide. So let's take a look at an I now. We have 24 orderings of I, and all collapse into just four I's, right? And divide by 4 factorial for it. Same thing for P's. Since there are two P's, you need to divide by 2 factorial for it because that's how many arrangements are possible. And same for S as well. Okay, so 11 factorial over 4 factorial over 4 and 2 factorial gives you 34,650 arrangements. Okay, everyone. Now we're going to be understanding combinations with repetition. Now, this is the most tricky part of this lecture, and I think the most tricky part of understanding anything in permutations and combinations, right? I'll try to make it as easy as possible. We will cover this example, and I think it will make more sense. After this example, I'll show you the actual, I'll show you guys an animation, and then we will understand the actual formula, right? Okay, so let's just look at the question first. The idea is, consider you are at a smoothie shop. You have three fruit options. You have mango, banana, and strawberry, right? You're supposed to pick 4 scoops, and repeats are allowed. So order does not matter because the order of choosing anything in a different way does not matter because it all gets blended. So how many distinct options do you have? Okay. Now this is a tricky question, right? And this is the question of combination with repetition. Okay. So far, what we were covering were in the last lecture, what we covered was permutations and combinations where we had distinct elements, right? We didn't have repeating elements. And in this lecture, we are covering everything where repetition is also allowed. So understanding permutations where repetition was allowed was very easy to understand. But in this case, this is combination with repetition, right? They're saying you are at a smoothie shop, you have 3 fruit options to choose from. So you can choose any of them, first of all, any number of times. So I can choose 4 scoops of mango, I can choose 3 scoops of banana, 1 scoop of strawberry. And another problem that we have is that the order does not matter as well. So let's just see some distinct options that we can find for this question first. Okay, so one distinct option could be this, right? All mango scoops. I can say another option would be um, I can say MBBM. Okay. Another option could be MSSM. Right. This is another option I have. Now, let me ask you guys this question first. Okay. Do you think this would be a different option? And the answer would be no. Why? Because in this question, repetition is allowed, but once again, this is combination. The order does not matter because the idea is we're making a smoothie. So SMS is the same as MSSM, right? So 2 mangoes and 2 strawberries is the same as this sequence because we are not caring about the order. And that's exactly why this is a very tricky problem and this has a different formula for it. Okay, so and I hope you guys understand what's the problem in this question, right? And I'm just giving a few examples to this. Okay, so now let's actually try a few formulas. Now, the first formula that if I was learning this for the first time that would come to my mind would be, how about we just try, since the repetition is allowed, right? And we have 3 fruit options. So why not just multiply 3 multiplied by 3 multiplied by 3 multiplied by 3? That's what we did for a lot of questions so far that we covered. This would result in the value 81. But the problem is that this would be incorrect. And the reason is this, if we multiply this 3 multiplied by 3 multiplied by 3 multiplied by 3, and considering repetition is allowed, this considers MBBS. So if you consider one mango scoop, so if you consider 2 mango scoops and 2 banana scoops, this considers these two as different options. So if you do 3 multiplied by 3 multiplied by 3 multiplied by 3, it's considering both of these options as different. But in our case, we are saying the order does not matter. So we cannot let this happen. Hence, this formula of saying NR would be incorrect in our case. Okay, let's just try another formula now. Okay, so we are saying 3 multiplied by 3 multiplied by 3 multiplied by 3 is 81. Okay, now another option that I can think of is how about I divide it by r factorial, which is the options I pick. Right? That's what we did in the previous part too. Right? When we were solving and we were rearranging the word Mississippi, this is kind of a very similar problem to that. Why not I just divide it by r factorial, right? I have 81 options. So for whatever ways that I can rearrange them, let's just divide it by that. The problem is, let's just see what happens when you divide it, right? So r in our case is 4. So that means 4 factorial. If you solve it, this will come down to some value 3.2 something, right? I might be incorrect. It might be 3.25 or maybe 3.2, 3.7. But this would be incorrect. You cannot have 3.7 or 3.2 smoothies. So there's something wrong happening in this case. Look, the problem is that this formula of 81 divided by 4 factorial and anything divided by the r factorial, where r is the number of options you're choosing, that formula works when you have distinct elements. In our case, think about this, right? The problem is m, 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 m. Let's say you have m, right? There's only one way to arrange it. Okay? If you have m, b, b, m, there are multiple ways to, there's more than one. There are more than one way to arrange this option. So the problem is that in a different sequence that I choose, so if I choose 4 mangoes, if I choose 2 mangoes and 2 bananas, they result in different ways to arrange. 4 m's can only be arranged one time. 2 m's and 2 bananas can be arranged in more than one ways. I don't know the exact number, but it would be different ways to arrange it, right? So the basic idea of explaining what I've just explained so far, even if you had a tricky trouble in understanding it, my point is the n multiplied by n multiplied by n multiplied by n formula, this wouldn't work in their case, and n factorial by r factorial, this wouldn't work either. Any of the formulas that we have covered so far wouldn't work, and I've just tried to like provide an explanation of why these two formulas wouldn't work. Okay, let's just take a look at the examples now once again, right? I have m, 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 4 bananas. This is a distinct option. I have m, b, b, m. 2 bananas and 2 options, right? Anyways, we can arrange them. Let's say we have 2 strawberries, 1 banana, 1 mango. Let's say we have 3 strawberries and 1 mango. Let's say we have 2 strawberries and 2 mangoes, right? These are the distinct options. I want you guys to think about this, right? What really matters then in this question? Like, how do we actually make sure something is distinct or not? The answer is the count of the different fruits we are choosing. That's what matters in this question. So my idea is 2 strawberries, 2s, 2m's. That's what matters, right? This is a distinct option. 4m's is a distinct options we can choose. 3 strawberries, 1 mango is once again a distinct option. So this covers repetition, that's one. Second is that order doesn't matter. So we only care about how many count of each flavor we are picking. So 3 strawberries and 1 m's. So we need to figure out how many different combinations of ways we can pick. So this is 1 plus 1 plus 1, and we need to find all the other ways possible. Some of the examples would be, maybe you can pick 3 bananas and 1 strawberry. That would be another. So we have counted total 4 ways. But the idea is that we don't care now how, like, where exactly is the banana being placed. We don't care if in this sequence banana is at the end, or is it at the front, or maybe it's in the middle. That doesn't matter, right? The only thing that matters in this question, and whatever the combination with repetition is asking us, is the count of the elements that we have. So 2 bananas, 2 mangoes is one distinct element. 3 bananas, 1 mango would be another distinct element. Okay. Now let's try to actually understand this question, right? So since the only thing that matters is the count, this is what I'm going to do, right? I'm going to try to find a way to see what what's the best way to find a formula for this question? So let's represent flavors with a star. Okay, I'm going to represent the flavors with a star, right? And I'm going to represent every flavor with just a star. And my reasoning is very simple, right? We don't really care what flavor you're picking. The distinct flavor doesn't matter. We only care about the actual count of the flavor. And we will separate different flavors by a bar. Okay, so I'm going to represent each flavor with a star, and I'm going to separate different flavors by a bar. Okay, let me try to quickly explain what I mean. This might seem very confusing. Okay, my idea is I'm going to represent my sequence like this: mango, bar, banana, bar, strawberry. Okay, so my idea is I have 3 distinct flavors and I need to divide them. For that, I need 2 different bars. I don't need bars at the front or at the back. Right? Those are not needed. And what I'm trying to say is that if I need a smoothie with only 4 mangoes, then I can put 4 stars here and I can put 2 bars here. So this sequence would mean I need a smoothie with 4 mangoes and no bananas and no strawberries, right? I hope that kind of makes a sense. Okay, let's say I want 2 bananas and 2 strawberries. In that case, I can say bar at the beginning, right? Because I don't need any of the mangoes. 2 stars here means I need 2 bananas and 2 stars at the end. This would mean I need 2 bananas and 2 strawberries, right? Okay. Now, let's say I need 4 strawberries. In that case, I don't need any mango, right? I don't need any strawberry. So in the final case, sorry, I don't need any mango, I don't need any banana. So my 4 stars would appear. Okay. Once again, I'll just quickly try to summarize what I'm doing, right? My idea is that whatever we do, right, in this question, the only thing that matters is actual count of the distinct elements we are picking. Meaning 3 strawberries, 1 mango is a distinct count. 4 mangoes is a distinct count. That's what we care about. So I decided, okay, let me just represent it, each item with just a star. And we will separate different ones with a bar, okay? So I'm trying to kind of like make a formula using just this star and this bar symbol. And this is what I come up with. So if I want a smoothie with 4 mangoes, I say, okay, 4 stars separated by 2 bars. This means a 4 mango smoothie. This means a 2 banana and a 2 strawberry smoothie. This means that I don't need any mango, no banana, just 4 strawberries. And if you think about this, right, this represents each distinct value that I can pick, each distinct option that I can pick. Okay, so what I need to figure out is how many ways can we actually arrange this sequence of stars and bars? And that's the final question that we come down to, right? Okay, now let's actually try to understand how many ways can we arrange it. Okay, so consider I have these, yeah, I know this might get really tricky, but I just hope that you guys can pause the video and just take a step back and then watch it from the from maybe 15, I should say 5-10 minutes before. So, yeah. Now the entire idea comes down to we have these stars and this bar symbol, and that's what we need to arrange. Okay. So let's pick 4 of these boxes, empty boxes. Yeah. Yeah. The idea is that all I need to do is think about this, right? I need to find different ways to arrange the symbol. But what happens is, actually, I just need to try to find a way to figure out where can I put my bar symbols. So let's say if you put your bar symbols at the very beginning, right? You have only 4 options. You only have 1 option to fill the other remaining spots, which is just going to be the star. let's say instead you decided to put your bars in the first and the last position. The only option you have in the middle would be the stars. So my idea is that in order to find the number of arrangements of this sequence over here, you don't really need to find how many ways to arrange the stars. You just need to find that in 6 boxes, if you have 6 boxes, in how many ways can I place these 2 bars? And if you think about this problem, right, you have 6 options and you need to pick 2 options, and the order does not matter. If I replace this bar with this bar over here, that would be the same thing. So I want you guys to try to pause the video and solve the question that I'm asking, right? You have 6 options, which means you have 6 boxes, and you need to pick 2 choices, which means you need to pick 2 bars and arrange them. So, and the order does not matter. So how many options would you have? The answer would simply be the combination formula that we have covered, which is going to be C of 6, 2. And this would be the number of actual final answer to this question, which is going to be 6 factorial by r factorial n minus r factorial, which comes down to 6 factorial by 2 factorial 4 factorial. Okay. Now, I know this is kind of getting like very tricky, but let me just quickly summarize this question. The idea is you're going to a smoothie shop. You have 3 fruit options: mango, banana, strawberry. You're supposed to pick 4 scoops, right? Okay. And repeats are allowed. That means you can pick mango as much as you want. You can pick banana as many times you want, and you can pick strawberry as many times as you want, right? Since repetition is allowed, this is different from the combination that we have covered so far. Okay. And another problem that we have is the order does not matter, because it doesn't matter in combinations, right? And they've already given us the problem that since they're all going to just get blended, it doesn't matter. So my idea is that the only thing that really matters in this question is how many distinct counts of flavors I'm picking. So that means 3 mangoes and 1 banana is a distinct option I have. 1 mango and 3 strawberries is a distinct count I have. And those are the counts that I'm actually trying to find. So how do I do it? Okay, I say I'm going to represent each flavor with a star, right? Because the only reason I'm doing this, because the actual flavors don't matter, only their count matters. So I'm trying to represent it with a sequence. So I said, okay, let's represent each with a star, and we will separate different flavors with a bar symbol. So I made this kind of like a formula for it. Okay, so it's kind of like a signal. So if anybody reads it, they understand what exactly I'm doing. Think about I'm running a smoothie shop, and instead of me asking somebody what smoothie they want, I just ask them to fill out a star symbol formula, and from that I exactly know what they want. So this means, so what you do is you just separate different types with these bars. So if I fill 4 stars and 2 bars at the end, that means I need 4 mangoes and no bananas and no strawberries. If I have nothing at the left of the bar and I have 2 stars in the middle and 2 at the end, that means I need no mangoes, 2 bananas and 2 strawberries. So what this equation really means is, it simply basically means that I need to actually find how many distinct options I have for this, and that would be the answer to this question. Okay, so how do we actually find it? The idea is very simple, right? I have 2 distinct bars, so I need to find how many places can we arrange them. So if you have 6 boxes, wherever you place these bars, that's what we are trying to find. And how many ways can you place that? That is going to be C 6, 2, and that would be a final answer to this question. Okay, so I hope you were able to understand this question, and in the next part, I'll first give an animation for you guys to understand this everything once again, and then after that, I'll give the formula to this question, right? I hope you were able to understand this, but I hope you get this. The purpose of understanding this question was not just solving this question, but actually get the idea of where the repetition formula comes from, right? And that we will be covering after the animation. Okay, guys, so let's say you have 3 fruits, right? You have mango, banana, and strawberry, and you're picking 4 scoops, but the repetition is allowed, right? And orders don't matter. So each scoop becomes a star, and 4 stars and bars are going to divide these zones. So that smoothie is now a string star star bar star bar star. Okay, so every smoothie maps to one single string or one representation, I should say, right? These are some of the examples that we can just show you. So the idea is that you pretty much have these 6 empty boxes, right? Or these 6 empty slots. So you pick 4 stars and you pick 2 bars, right? So you can either put them in first two, or maybe you can put them in the third and the fifth. Or another example is maybe in the last fifth and sixth, right? And whichever combination you make, whichever sequence you make, it is a different unique sequence. So the idea is, since this gives you a combination, right, which is the formula 6 comma 2, and that exactly is what the general formula is based on. So the idea is, if you have r stars and you have n minus 1 bars, which is the vaults, the total slots would be n plus r minus 1, and the total, the formula would be c n plus r minus 1 comma r. Okay, everyone. So I hope you were able to understand the animation. Now the formula is actually very simple. I spent a long time explaining, and I'm sorry if I wasted a lot of your time. But the formula is actually not very difficult. But my entire point of such a huge explanation was just so that you actually know the meaning of the formula and why it is the way it is. Okay. So the problem is, so let's say if you have r items in general and you're supposed to choose from n types such that the repetitions are allowed and the order does not matter, which in very simple words means if it's a question of combination with repetition, then the formula is C. First term is n plus r minus 1 and r is the second term. So this would be a formula in that case. Okay. So C n plus r minus 1 comma r is equal to the number of ways to place r stars with n minus 1 bars. And this is the idea that comes from what I explained in the previous part, right? Okay, so the idea is very simple. I'm saying you're supposed to place r stars, right? In last case, we had different flavors. We were supposed to pick different flavors. We were supposed to pick 4 scoops, right? So we represented 4 scoops with 4 stars, and we represented different types with the bars, right? And remember, we're not putting every bar at the ends as well. We just pick the bar where we need separation. So hence, since you just need it where you need separation, that's why it's n minus 1, right? I hope the n minus 1 makes sense. So for example, let's say in our case, strawberry, banana, mango. So these are actually, so the value of n over here is 3, right? N equal 3 in this case, but the bars we need is actually 2 because we are not placing bars at these two ends as well. That's why the number of bars equal n minus 1, which is equal to 2 in this case. Okay, so I hope you were able to understand. And why is the formula C n plus r minus 1 r? Because it's pretty much that we consider those stars and those bars and we try to figure out how many ways can we actually arrange these bars, right? And that formula comes down to C n plus r minus 1 comma r. Okay, so one final example before I give you guys questions. So 7 identical balls and you're supposed to place them into 4 boxes. This is once again a question of combination with repetition, right? Yeah. So the idea is I can place, since they're identical, that means repetition. And you have 4 boxes, that means the order does not matter, right? So the order and repetition are, order does not matter and repetition is allowed. So once again, let's just represent these with stars, right? You can represent this with 7 stars. So you have 1, 2, 3, 4, 5, 6, 7, right? And 4 boxes, I can separate them with 3 bars, right? So that means this would be 1, this would be box 2, this would be box 3, and this would be box 4. So that's why I need n minus 1, so 4 minus 1. So once again, I can place 2 stars over here, which means I can place 2 balls in the first box, 2 in the second, no in the third, and maybe 3 in the fourth one. And hence I can make this arrangement as many times I want. So the only thing that I actually need to figure out is the placement of these 3 bars. So if I have like 7 plus 3 bars, which is 10, I need to figure out how many ways can I arrange that. So my answer basically comes down to C n plus r minus 1 comma r, which is going to be n in our case is 7 plus r, which is 4 minus 1 comma 4, which is 7 plus 4, which is 10 comma 4. So 7 balls, 3 bars, which is 10 times. So all we need to figure out is if I have 10 empty boxes, how do I place 3 bars into them, which is the formula that comes down to this over here. Okay, so very big lecture, I think, and I think a lot of explanation going on, but I try to explain it as much as I can. The idea is that these formulas are very simple to understand, but I just thought that it's important that you guys actually understand the reasoning behind the formulas too, because I think that's super, super important. Okay, now I'll be giving a bunch of questions, but since the lecture is getting like extremely long, I'll not be solving these questions, but instead I'll put the answers in the comments or just attach the animation of the answers. Okay, so I'll see you guys in the next video. I'll be giving like a picture of the questions that you need to solve. Okay guys, here's the first question. And the question is 3-letter password from ABCD, repetition is allowed. So very simple question. Now pause and try. So since repetition is allowed, right, and we have 4 letters, so it's pretty much just going to be 4 multiplied by 4 multiplied by 4, which is 64 is the answer. Okay, let's move on to the next question. So distinct arrangements of a balloon, you have 7 letters, right, which is 2 L's and 2 O's. Now remember what we studied about repetition of letters. Okay, once again, the answer is going to be basic, which is 7 factorial by 2 factorial multiplied by 2 factorial. Okay, now the final one, which is 5 fruit types, pick 3 scoops, and repeats are okay, order doesn't matter. Once again, this is going to be the C n plus r minus 1 formula, and here's the answer that you get. So I hope you liked the lecture, and I'll see you guys in the next video.